All right, hello everybody. Welcome back. This is going to be our final video that we do for chapter 23, and that's from the Statistics Modeling Our World curriculum. And what we're going to be doing in this video is finding the critical t value in a confidence interval. So, a couple quick things about the students' T models that we've been using. So they're all unimodal, symmetric, and bell-shaped, just like the normal model. However, since T models have that extra bit of variation in them, the sample size, or the degrees of freedom, remember degrees of freedom is sample size minus 1, has an impact on just how much variation is in that normal model. So to see a picture of that, we've got two different normal models here. This solid blue line is a T model with 2 degrees of freedom, and the dotted line is a standard normal model, the same normal model that we used when we were finding z-scores for the proportions test. Notice that the T model with 2 degrees of freedom has a much fatter tail. Okay, it is higher as it goes out. Notice that it's right around from here on out, right? The T with 2 degrees of freedom is larger in that place. What that means is that this has more variation. And as the sample size increases, which means as your degrees of freedom increases, that amount of variation will decrease. As the degrees of freedom increases, it starts to look like the normal model. In fact, if you have an infinite degree of freedom, it is exactly the normal model. So the more degrees of freedom you get, the more this particular graph will get a little bit smaller and closer to what this normal model looks like. This is my poor artistic representation of that. But as your degrees of freedom increases, that's going to change and get more close to the normal model. So what that means is, for our confidence intervals, remember a confidence interval is always the test statistic plus or minus the margin of error. Now, the margin of error is defined differently depending on what kind of confidence interval you're finding, but they both have means tests and proportions have the same something in common in that you have to find this critical z. For the proportions test, it was critical z times the square root of p hat q hat over n, and for these proportions tests we've been doing, it's been the critical t value with the degrees of freedom times s over the square root of n. Okay, but notice that in both cases it's the critical value times the standard error. And on the AP exam, you will have some questions that you need to find this critical value. Now, we did this in a previous video with proportions, but we're going to do it again here. And I want to just inform you that it is the same logic. So let's draw a normal model and let's talk about what that logic was to find the critical value. So there's my normal model. If I wanted to talk about a 95% confidence interval, I'm talking about the middle 95% on a normal model. Remember, we get that 95% because the area beneath this curve is 0.95. And what that tells us is if this is 95%, then this over here is 2.5%, and that this over here is 2.5%. And what we need to do, the critical value, is this point right here. The critical value is that point where if I take the middle 95% or the middle 90% or the middle whatever my confidence is, the critical value is this side of that. Now, in a T model, it's going to make a difference. The sample size is going to make a difference, right? Because the family of T models is going to change where this point that's 95% is. So you can calculate this by hand. Doing that, this is a T table. You'll find these in the back of any statistics book. You can also look them up online. Okay, it's been around for a long time. If we're doing it on a T table, all we need to do is look at this line here that says two table probability. That means that we're looking at both sides. So two-tail probability is confidence, is like a confidence interval, because we're looking at both sides. So this 0.05 right here is 95%. And this one that's 0.0, that's a 95% confidence interval because 95 plus the 5% on the outside makes 100. And this is a 90% confidence interval because 90 plus 5 plus 5 makes 100. And this one would be an 80% confidence interval. And so all you need to do to find that critical T value, if you're using a T table, is go to the confidence that you're at, and then go down on this table until you get to the number of degrees of freedom you have. So let's say our sample size was 10. That means our degrees of freedom was 9. And so the critical T value would be 2.262. Now let's say we had a 90% confidence interval and our sample size was 20. That would make our degrees of freedom 19. And therefore our critical T value would be 1.729. Now, the tables work really well. The unfortunate thing is that you will not have a complete list of the various confidences you can have. Anything in between 90% and 95%, you're going to have to estimate. And typically speaking on the AP exam, you don't want to have to do that estimation. So we need to be able to do this. We want to be able to do this using technology as well. So I want to show you what to do on a TI-84 calculator as well. Again, remember, this is the key, right? We're looking for this point. So let's back out of this and look at our calculator, which I didn't open ahead of time because I'm a terrible person. Ooh, there we go. So we are trying to find, let's go ahead and just do like an example here. Let's do a 95% confidence interval. And let's say my sample size is 25. So I want you to remember this picture. 95% confidence means 95 in the middle and then 2.5 on each side. Okay? And remember that we are looking for this point right there. We're looking for, remember this would be our mean right here. That's 0. We're looking for this point. Where is the right side of this interval at 95%? Now, we can't just use the normal because this is a T model. It's got a sample size of 25. I want to remind you of how the calculator works. The command we're going to use to find this, because remember, this is finding a z-score or a t-score. Finding a t-score commands are the inverse commands. So we used inverse norm before when it was a z model, but this is a t model, so we're going to use inverse t. So the way that inverse t works, the way that the calculator works, is you're going to type in a number, okay? And the number that you're going to type in, let's just say it's 0.5, okay? What your calculator does is it starts way over here on the negative side, and it goes, I'm going to take the area underneath the curve, and I'm going to continuously add it up until I get to 50%. And so if I were to put 50% in there, it's going to give me 0, because I continuously added up the area beneath the curve until I got to 50%. So let's just let me just show you. If I were to put in 0.50, and then I need to put in the degrees of freedom. In this case, degrees of freedom is 24. This should give me 0 because it's counting 50%. It's adding up the area beneath this curve over and over and over until it reaches 50%. And then once it reaches 50%, it stops and it gives the output. So what we need to do for a 95% is we need to tell our calculator, okay, keep adding up the area beneath the curve. Here we go. We're adding it up. We're adding it up. We're adding it up. But we want it to stop at a certain point. The question is what number do we put in to make that happen? Well, it's not 95%, because 95% is just this part in the middle. It does not take into account the part over here. 95% is going to stop us somewhere around here, because it's going to go 0, 50, 95% is right about there, right? It's not going to go all the way to this point over here. We need to tell our calculator to go all the way to this spot. So it needs to add up 95%, because that's the area over here, but it also needs to add up this percent that is on this side, and that's 2.5. So we add those two things together, and it's 97.5. So what I need to enter into my calculator is inverse t, and because I want 95% confidence, this needs to be 0.975, because it's the 95 in the middle and the 2.5 over here, so that I get this spot right here. It's 95 plus 2.5. And because this is a T model, I need to enter my degrees of freedom, which is 24. And that's going to give me 2.06. So the critical T value right there is 2.06, and that is what you would use as the critical T in your confidence interval. And again, just to prove this last fact to you, we said a little bit earlier that the Z model, as you get closer and closer, as your T model gets a higher and higher sample size, higher and higher degrees of freedom, it becomes closer and closer to the Z model. Now, I don't know if you remember this from our previous videos, but on a typical Z model, this value right here is 1.96. That's not an accurate to scale drawing. But this value is 1.96 on a Z model. Notice that our 95% that we did here was 2.06, kind of far away from the 1.96. But if we increase the sample size, we'll start getting numbers that are closer and closer to 1.96. So if I did inverse T of 0.975 comma 50, doubling the sample size, we're going to get 2.00. So notice it's gone down, a little less variation, a little bit closer to that 1.96. Let's double it again. Inverse T, 95% confidence is 0.975. And we'll do 100 sample size this time. And getting closer, 1.98. So notice that the larger this gets, the closer it does get to that 1.96. So T models at an infinite degrees of freedom is the 1.96. It's the same thing. It is the exact same model. Okay. One last quick example, just so we can do it with something other than 9. Let's do something that's a confidence that is kind of like random, right? Let's do 88% confidence. Now, in terms of like actual research, I don't know if anybody would ever use an 88% confidence interval, but let's use this wacky example just to show what's really happening with our calculators, right? 88% confidence, and let's use 66 as our sample size. So let's draw the picture just so we understand what we're doing. Remember, we're using inverse T. 88% confidence means there's a section in the middle that is 88%. And what we're looking for is that critical value right there. But simply putting in 0.88 won't work because our calculator starts on this end and adds everything up. So if this is 88% in the middle, that means that there's 12% on the sides, on the tails, which means each tail is 6%. So the number that I actually want to plug in, because I want it to take the 6% that's right here, and then the 80% that's right there, is 88 plus 6, or 94%. So I'm going to switch my thingy here. I'm going to do a inverse T command, and it's going to be 0.94, because that's what my 88% confidence interval will be. And then my sample size is 66, so my degrees of freedom is 65. And there's my critical T value right there, 1.575 is that value right there. Which again, if we were doing an 88% confidence interval, we would have our test statistic plus or minus 1.575 times the sample standard deviation over the square root of 66, because that's our sample size. And that's all I've got for you today. Thank you for watching. If you've got questions, remember you can always ask them in the comments below, or find some way to contact me, and I will happily answer to the best of my ability. Hope you have a fantastic day. Thanks for watching. Bye.